Hi guys, and welcome back to Aisha.Academy again. So today I'll be going through the AQA GCSE Higher Probability and Statistics 2021 assessment material. So let's get right into it. Okay, so first things first, it says a music festival has taken place each year from 2011, and it's just showing a table of the number of people that attended each year. So it says the festival organizers draw a time series graph to represent the data. The first 4 years have already been plotted. So let's have a look at the graph. So as we can see that there's 4 crosses, so they've already plotted from 2011 to 2014. And then the question is now saying it wants us to complete the graph. So literally, you're just going to plot the values that they've given from the table onto the graph. So let's have a look. So I'm just going to do it as I go along. All right, so first things first, it's saying that in 2015, there were about 2,023 people. And I know you're probably going to ask, how am I going to draw exactly 2023? You're just going to have to roughly draw that. So first things first. So 2015. So here is marking 2,100. As we can see, each part is going up in hundreds. So then if you're trying to draw 2023, it's going to be slightly less than halfway of that, so about there. And then for 2016, there was 2,612 people. So 2016, 2,612. So this is 2,600 right here. So 2,612 will be slightly higher than that. So that will be about here. Then it says 2017 was 3,251. So 3,200, where is that? That's about here. So then here. So then 3,251 will just be slightly over halfway between 3,200 and 3,300. So about there. And then in 2018, there was 3,780. So if we mark that on, so 3,780. So that would be about, so 3,700 is here, so 2,780 will be the slightly higher end of that part, closer to 3,000. Oh, I've just crossed it out. So closer to 3,800. So about that. Actually, slightly more. Not me trying to be accurate, but yeah. So about there. So then complete the graph, so just connect the lines. So I'm sure you guys will be neater on paper with your rulers, draw nice straight lines connecting the points. So then part B is just again the same graph, but the only difference is they're probably going to ask a different question. So then now they're saying that use the graph to estimate the number of people that will attend the festival in 2019. So I'm going to go back to this one because I've drawn on here and just to be able to draw twice. So then if I make that nice and straight, so then 2019 would be about here. So let's look at the rate, right, from where we've drawn. Let's look at the table. Okay, so we can see that roughly approximately it's about just over 550 each time. So then what now I'm going to do as a shortcut is I'm going to work out the difference between 3,780 and that 2023. So that would leave me with 3780. So I'm just putting into my calculator minus 2023. That's about 1,757. Then that's because of over 3 years. I'm going to divide that by 3. That's going to give me a rough estimate each year. So that's about 585.6 recurring. Okay, so about 585, 586 each year. So now I'm going to add that on to the 3,780. And that's about 4,366. So that's the point I'm going to roughly draw on the graph. Obviously, if it's come up in your paper twice, draw it twice, but I'm just drawing it once. Okay, so 4,365. So that's about 4,300. So then the 65 would be just slightly halfway above that. So I'd say, based on the common trends, because remember you're estimating, estimates are not accurate. So then I'd say in about 2019, 4,365 people attended. Okay, So it says a coin is thrown 50 times and it lands on head 31 times. And it wants us to write down the relative frequency it lands on heads. So 31 is heads out of the 50. So 31 divided by 50 is 0.62. So you can either write it as a decimal or you can write it as a percentage, which would be 62%. Then it now says Raj says that the coin is biased towards heads, so use the data to give a reason why he might be correct. Well, we know that on a coin you've got heads or tails, so theoretically that should be a 50-50 chance. So on a coin you have heads or tails, heads and tails. So it should be 0.5 for heads. So it should be 0.5 for heads, but it's not. So that could be a reason as to why probably the coin is just biased towards heads, because your heads value is 0.62, which is way more than what we would expect theoretically. So that's why he might be correct based on that data. Okay, then it says that a spinner has an equal sections numbered 1, 2, 3, 4, and 5, but a six-sided dice has five red faces and one green face. It says the spinner is spun. If the spinner shows an even number, the dice is thrown. So it says complete the tree diagram. So it says that only when the spinner shows an even number, the dice is thrown, not when it's odd. So first of all, your even numbers are 2 and 4. So you've only got 2 out of 5 even numbers. So you've got 3 out of 5 odd numbers. So it's only when the spinner lands on even, the dice is thrown, not when it lands on odd. So you wouldn't need to draw any extra branches from odd. So then you've got red faces or you've got green. So because you've got 5 red faces out of the 6-sided dice, you've got 5 out of 6 would be red and 1 out of 6 would be green. And that would it be complete. Then it now is again a follow-up question, and it now says work out the probability of getting an even number and the color green. So let's have a look. So the probability of even is 2 out of 5. The color green is 1 out of 6. So you'd have to multiply them together, which would leave you with 2 out of 30, because remember when you multiply fractions, you multiply the two numerators together, then the two denominators together. Simplify this fraction, so divide both top and bottom by 2. That should give you 1 out of 15. Okay, then in the next question, it says, here is some information about the marks of 60 students in a test. And it says, on the grid, it wants us to draw the cumulative frequency. So first things first, we're actually going to complete a table for the cumulative frequency. So the cumulative frequency, remember you add the frequencies as you go down. So the first one would just be 9. The next one will be the 9 plus 16, which is 25. The next one will be the 25 from the following on plus the 20, which would be 45. Then it would be 45 plus the 8, which is 53. Then it would be 53 plus 7, which would be 60. So these would be our values of our cumulative frequency. So we need to plot them on. So always remember with cumulative frequency, you're plotting from the higher end of the ranges. So that would mean that at 50, we plot the 9, not at 40, at 50. Then at 60, we're going to plot the 25. So at 70, we're going to plot the 45. At 80, we're going to plot the 53. And at 90, we're going to plot the 60. Okay, and then cumulative frequency is kind of like your S-shaped graph. So you want a nice curved graph. So don't draw straight lines, draw a nice curve. Obviously, yours would be neater than mine. So then, now moving on, we've drawn it on there. And again, it's just drawn the same graph again. So it says use your graph to now estimate the lowest mark of the top 20% of the students. So we know we have 60 students. So 20% of 60 would be working out basically 60 divided by 100 times 20. And that should leave you with an answer of 12. So we're looking at the top 12 students. So because you're looking at the top 12 students, you're not going to be looking at up to here of 12. No, because that's the lower mark ranges. This is top 20% of students. So you're going to do 60 minus 12, which would give you 48. So then you're looking between here and here, because that's where 48 is. So you're looking at from the highest mark to that mark there. So 48, if you go down, and then the highest mark was 90. So the top 20% of students range between these marks. So their marks would range between 73 to 90. So because the question is saying you want to estimate the lowest mark of the top 20%, well, the lowest mark would be the 73 of that range, because that's the lowest mark within the top 20% of students. Okay. Then it now says, in a choir, there are 35 men and 48 women. It says the probability that a man chosen is to wear glasses is 2 out of 5, and the probability that a woman chosen is to wear glasses is 3 out of 8. So it wants us to work out the number of people in the choir who wear glasses. So in order to work out the number of men that wear glasses, we're going to do 35, because there's 35 men, times 2 out of 5, because that's that probability of a man wearing glasses, and that would leave you with 14. For men. Then for women, it would be 48 times their fraction, which was 3 out of 8, which would be 18. So then you've got 14 men wear glasses, 18 women wear glasses. So if you add those together to work out the total people that are wearing glasses, that'll be 32 people wearing glasses. And that's your answer. Then again, same question, but follow up. So this time it says work out the probability that the person does not wear glasses. So in total, I'm just zooming out so then we can see the total number of people wearing glasses, because that's going to help us. So then the total number of people is the 35 men plus the 48 women. So that would give you a total of 83 people. So there's 83 people. So if we know 32 wear glasses, then the people that don't wear glasses would be 83 minus 32. And that would be 51. No, it would not be 51. Yes, it would be 51. Not me doubting myself. So it would be 51. So then we know 51 people don't wear glasses, but because it wants us to work out as a probability, we need to write it in the form of a fraction or as a percentage. Because remember, we can't leave probabilities as just whole numbers. We're not working out the number. So it'll be 51 out of 83 people. Can we simplify this? No, we cannot simplify it. Also because 83 is a prime number. So then that would be left as 51 over 83. Okay, so moving on, it says that here is some information about the ages of people at a concert, and it wants us to draw a histogram. So here's the graph that we're going to draw it on. So first thing when it comes to histograms is histograms, you need to work out something called your your frequency density. Because as we can see down here, if I scroll down, your frequency density is the y-axis. We need to work out the frequency density. So our frequency density is frequency over class width. So that in this case, it would be 8 divided by 5, because the class width is the difference between the highest and the lowest value in the width. So that would be 1.6. Then 24 divided by 10, which would be 2.4. Then 30 divided by 15, which would be 2. And then 39 divided by 30, which would be 1.3. Okay, so then now we've worked out all those values. The next thing is we need to actually plot it on. So remember, histograms are your bar charts that are squashed together. So the first bar is 10 to 15, and the frequency density is 1.6. So that would be here. And the next bar is from 15 to 25, and then the frequency density is 2.4. So that would be there. Then the next one is from 25 to 40, so then the frequency density would be 2. And then from 40 to 70, it was just 1.3. So that would be there. Again, yours would be neater because you have a ruler and it'd be on paper. All right, and that's it. Then it now says, next question. Naga, I think it's Naga, states a hypothesis that most people read more than 100 books a year. She asks a sample of 5 people in a book club of how many books they read in the last month. So here is the table showing that. So it wants us to show that Naga could use her data to support her hypothesis. So what we're going to do is work out how many books a year each person reads. So we know in a year there are 12 months. So for Lynn, it would be 10 times 12, which would be 120 books a year. For Ali, it would be 11 times 12, which is 132. For Paul, it would be 8 times 12, which is 96. For Chen, it would be 10 times 12, which is 120, like Lynn. And then for Ruth, it would be 13 times 12, which is 156. So now that we've worked out how many books each person reads a year, to work out the mean of all of that, because you're working out most people that read, to work out the mean out of the 5 people she's chosen, so you're going to add them all up. So 120 plus 132 plus 96 plus 120 plus 156 and divide it by 5 because it's out of 5 people and that's your mean. So to work out the mean is 124.8. So we know that the mean of the number of books a year out of the 5 people chosen is 124. And 124.8, which is roughly 125, is greater than 100. So therefore, this supports a hypothesis. Okay, so now again, same question, but follow up. It wants us to give 2 reasons why this sample should not be used for a hypothesis. First of all, 5 people is a very small sample size. So first thing is sample size is small. Second of all, this could be biased because this is only people in a book club. This is not worldwide. This is not like comparing different countries. This is just in her book club. So biased as it only uses a sample of individuals from the same book club. So that's that. Okay, so moving on, it says in a sport, injury time is added time played at the end of the match. So it says the table shows the injury time played in 380 matches. Okay, here's the table. Then it now wants to circle 2 words that describe this data. So let's have a look at this table. So first of all, anything to do with time is continuous data because discrete data is like specific values. So an example of that is for like your continuous data. So things like time, height, like a weight of something, like they're not really specific values because you can have like decimal places with that. But things like discrete data could be more accurate and specific values, such as how many cats does Paul have? You can only have like cats as a whole number. You can't really have point something of a cat, if that makes sense. So discrete is more specific, so whole numbers, whereas continuous can have like decimal places. So in regards to time, you can have like 1.5 minutes. You can't really just have set 1 to 2 minutes. You can have all those different things. So it would be continuous data. Then now, as we can see, they've kind of grouped them and they've got different frequencies for the groups. So I'd say it's grouped and continuous. Then again, they're showing the same table, but this time it wants us to work out the class interval that contains the median. So to work out your median, you always do the total plus 1 divided by 2, which is 190.5. So we need to see where roughly a frequency of 190.5 is lying in between. And I say it's lying here because if you have a look, you've got the 59 and then 158. So if you add 59 plus 158, you get, so let me put that in quickly. 59 plus 158 gives you 217. So we can see it's roughly falling in between this range, so between that class interval. So I'd say between the 2 and the 4. Then moving on is now going on to a different question. So this is the last question to do with box plots. So it's showing these two box plots of team A and team B. So this one's A. I don't know why it's printed out like this, but A and B. Then it now says, on average, which team runs faster? So here's where they're tricking you. You're probably going to think, oh, A, because A has the highest value. No, it's saying on average. And we know the average that we use in box plots is your median. And your median is represented by the middle lines. So we can see that the average of A is actually higher. So on average, team A run further than team B. And it wants us to give a reason for our answer. So our reason is because the median for team A is higher than the median of team B. And you can actually work out the values. I would recommend anyway, because you never really know what examiners can be like. Use values to compare and represent that. So in terms of team A, our median, it's looking like it's falling on 9.8, whereas for team B, it's 9.7. So as 9.8 is greater than 9.7. There you go. And then the last bit, second to last bit, I kind of jumped the gun. There's still a few more questions, but moving on. So it says the players in Team A ran at more consistent distances. So how does the box plot show that? Well, what we can see is the box bit of your box plot actually represents your interquartile range. So if we work out the interquartile range for Team A, so the upper quartile is 9.9 and the lower quartile is 9.5. So if we did 9.9 minus 9.5, our interquartile range is therefore equal to 0.4. And 0.4 is really small. So if your range is smaller, that means it's more consistent. If you had a bigger range, that means you had more variety and it's less consistent. So our IQR is 0.4. So this shows that Team A ran more consistent distances, meaning that the distances that each player ran were more similar. Okay. Then moving on to the next question. So it then goes on to say that in question 16, a running club, there are 50 females and 80 males. So it says if a female is chosen at random, the probability that she has blue eyes is 0.38, whereas if a male is chosen at random, the probability that he has blue eyes is 0.6. So it says one person is chosen at random. It wants us to show that the probability that the person has blue eyes is more than 0.5. So let's have a look at this. So first things first is that we've got a total of 130 people, because 50 plus 80 is 130. So for the blue eyes, so the amount of females with blue eyes would be the 50 females times 0.38, which would be 19. Then the amount of males with blue eyes would be 80 times 0.6, which would be 48. So 19 plus 48 would leave you with an answer of 67. And then now we have 67 people with blue eyes. So because it's 67 out of 130, we know that for 0.5 of the people to have blue eyes, that would be 65, because 65 is half than 130. So we can happily say that 67 out of 135, so out of 130 is more than 0.5. And that's us showing that the probability of people with blue eyes is more than 0.5. Or you could actually work out 67 out of 130 as a decimal, which in your calculator, it would leave you with a really long decimal of 0.51538 ... So we can see that that is more than 0.5. So therefore, that's showing that. Then this is the last question. The last question is a Venn diagram. So it says that A and B are two events, and it says some probabilities are shown on the Venn diagram. It wants us to work out the probability that not A, you can have not A or B. So not A would include all this part and the outside part, which, cheeky, they haven't given us the decimal for the outside part. So we know the total probability is 1. So to work out the outside part, you do 1 minus 0.3 minus 0.15 minus 0.35, and that would leave you with 0.2. So the outside is 0.2. Okay, so not A is including all this part, but you want not A or B. So this is different to not A and B. So if you've got the U up, it means or. So and is just strictly those regions, or is a possibility. So the possibility of B is also in that range as well. Because remember, there's some B in the middle part. And because it's not A, you're also going to include the outside part as well, because the outside part means not A or B. So it could include that. So we would add all those decimals together, but not the 0.3, because that's part of A. And then that would leave you with 0.7. So the answer is 0.7. Or another way of working it out is just doing 1 minus 0.3, since that wasn't included. And that's the end of that paper. So I hope that was useful, and thank you so much for watching.